Howdy y'all, Mr. Causey coming to you from beautiful Atascocita, Texas, and today I'm going to have a homework helper on stoichiometry and word equations. You'll need a periodic table, you'll need a polyatomic iron chart, and you'll need your calculator. I'm going to make a few assumptions. First, that you know how to write chemical formulas, that you are familiar with moles and molar mass, that you know how to write a balanced chemical equation, and that you know how to use the periodic table. And if you're not familiar with any of these things, go to my YouTube channel and watch the videos on these subjects. Here's the problem. 10.6 grams of magnesium reacts with excess hydrochloric acid to produce hydrogen and magnesium chloride. How many grams of hydrogen will be produced from this reaction? Now, we don't have to worry about limiting reactant because we are in excess hydrochloric acid. But we do need to figure out how we're going to go about this, getting our grams of magnesium to grams of hydrogen. And we're also going to need a chemical equation to help us. So, let's first outline what we're going to do. We're going to take 10.6 grams of magnesium and determine how many grams of hydrogen were made. Thus, we need to go from grams to moles, and then to moles, and then to grams again. We also realize that we have magnesium reacting with hydrochloric acid to produce hydrogen gas and magnesium chloride. Let's make out a plan. 1, let's determine the reactants in the products, and we've already done that. 2, let's write a balanced equation. Now, we wrote an equation, but it wasn't balanced. 3, use molar mass to change the grams of magnesium to moles magnesium, and we can get that right off of the periodic table. Then we want to use our mole ratio to change moles of magnesium to moles of hydrogen. Then we're going to use the molar mass of hydrogen to change it to grams of hydrogen. Here's our chemical equation, and let's balance it. Notice that there are 2 hydrogens and 2 chlorines on the right side, but only 1 on the left side. So let's go ahead and change our coefficient there, and now you'll notice that there are 2 hydrogens and 2 chlorines on both sides, and 1 magnesium and 1 magnesium. So it's balanced. Now, let's determine our mole ratio from this balanced equation. And our mole ratio, if you notice, there's 1 magnesium to 1 hydrogen. We don't write ones, just like we don't write 1x in algebra. But that gives us a 1-to-1 ratio, which is going to make our work very simple. And then our molar mass of magnesium, well, let's go to the periodic table, and you'll see that the molar mass of magnesium is about 24.31, and that the molar mass of hydrogen is going to be about 1.01, but we have 2 hydrogen atoms in that molecule, so it's going to be times 2. And so our values are going to be 24.31 grams and 2.02 grams. Now, with all that information, let's set up the problem. Here are our calculations. We're going to have 10.6 grams of magnesium times our molar mass, and we got that from the periodic table. And then we're going to multiply that by the mole ratio, and then we're going to multiply the mole ratio by the molar mass of hydrogen. Now notice we've set this all up so that our units will cancel out with the proper unit analysis. Grams of magnesium cancel out, moles of magnesium cancel out, moles of hydrogen cancel out, and we end up with grams of hydrogen. Put that into our calculator. Let's plug and chug. And we should get an answer of 0.881 grams hydrogen gas. And that's with 3 sig figs. All right, let's recap. You wrote and balanced the equation. You determined the mole ratio. You calculated the molar masses. And you found the grams hydrogen. Good job. If you have any questions, send an email to mrcausey@mrcausey.com. And be sure to check out mrcausey'sworld.com for videos and much, much more. And subscribe to my YouTube channel. Studies have shown that it increases your IQ. Happy eyeing, y'all.